Linear independent. How you can tell whether the given set is a linearly independent or it is a linearly dependent set. For that purpose, you must know the exact definition that what linearly independent means and what linearly dependent means. If you are given with a set of vectors v1, v2, v3 up to vn, this set is a non-empty set of vectors in a vector space V. Then the vector equation. Which vector equation? k1 v1 k2 v2 plus up to kn vn equals to 0 vector. And what are these k1, k2 and kn? All these are scalars and these are unknown here. Has the trivial solution if you are given with a set of vectors and you have written it in the vector equation like this, and you found the values of k1, k2 up to kn after solving this vector equation, and it gave you some trivial solution. What trivial solution means? It means your k1 equal, k2 equal up to kn equals to 0. If all of your k's are equals to 0, then this means it has a trivial solution. And if you got a trivial solution, then this means that the given set of vectors is linearly independent set. And if your k1, k2 and up to kn are not equals to 0, then you will say like your given set is linearly dependent set. So what you have to do for finding whether it is a linearly independent or dependent? First of all, you have to write down its vector equation. Solve it for k1, k2 and kn and get the values of k1, k2 up to kn. If you got a trivial solution, then this means this given set of vectors is linearly independent set. If they are not equals to 0, then this means it is linearly dependent set. Now let's move on to the example so that your concept becomes more clear. Check whether these vectors v1, v2, v3 are linearly independent or linearly dependent in R3. Now for checking that whether it is a linearly independent or dependent, first of all you have to write down the vector equation. And what is your vector equation? Your vector equation is k1 v1. You have 3 vectors, so you will write up to k3 plus k2 v2 plus k3 v3 equals to 0 vector. Now fill it. In place of v1, put the value of v1, v2 and v3. We will get here k1. Put the value of v1 here, that is 1 minus 2, 3. Plus k2, put the value of v2 here, that is 5, 6, minus 1. Now put the value of v3 here, that is 3, 2 and 1. Now it is equals to 0 vector. Now all these coordinates are from R3. So your 0 vector will also be from R3. Like this. Now simplify all these terms. Multiply k1 inside. You will get here k1 minus 2k1, 3k1. Now multiply k2 inside, we'll get here 5k2, 6k2 minus k2. Now multiply k3 inside, you'll get 3k3, 2k3 and k3 here. That is equals to 0 vector. Now add all these vectors. First entry will be added up with the first entries. Second entries will be added up with the second entries. And the third entries will be added up with the third entries. And you will get here k1 plus 5k2 plus 3k3 first entries, all first 3 entries. Then minus 2k1 second entries plus 6k2 plus 2k3. Now third entries 3k1 minus k2 plus k3, and the whole vector is equals to your 0 vector. Now what you have to do, you have to equate both sides. The first entry will be equals to the first one. The second entry will be equals to the second one, and the third entry will be equals to the third one. So equate them, you will get here a system of equations. K1 plus 5K2 plus 3K3, that will be equals to 0 from the first coordinate. Now second coordinate will give you minus 2K1 plus 6K2 plus 2K3, that will be equals to 0. And the third entry is 3K1 minus K2 plus K3 is equals to 0. Now you have to do what? You have to solve it using Gauss elimination method. How you will solve it? You will write it in a matrix form. Now K1, K2, K3 will not be written, only their coefficients will be written. First of all, just have a look on it if whether the equations are arranged as the similar way or not. First of all, write K1, then K2, K3, all the equations are arranged in the same manner. So write the coefficients 1, 5, 3, minus 2, 6, 2, 3, minus 1 and 1. And now write these zeros. Now you can do here the column operations and you can do here the row operations. I am doing here the row operations. And what row operation I am doing here in the first step? First of all, I will try to make the entries here 0. I am making it as the lower triangular matrix. The diagonal entries are these. The lower, and I will try to make the lower entries as 0. For that purpose, I am doing what here? I need to do it here the 0. For that purpose, simply minus 2 plus 2 times this row. So it will be R2 plus 2R1. This entry will be 0. Now this entry, how you will make it 0? It will be 0 if you have 3 minus 3 times 1. So it will be R3 plus minus 3 times R1. Now apply these row operations here. The first row will remain as it is. Now this is R2, so the whole operation will be operated on R2. Follow this thing. Minus 2 plus 2 times R1. 6 plus 2 times 5. 2 plus 2 times 3, and similar manner, so on. You will get here 0, 16, 8 and 0. Now the same thing you have to do with the R3, row 3. You will get here 0, minus 16, minus 8 and 0. Now I can make the last row completely 0. How? If I add this complete row with the second row, I will get here 0. How you will write it? You will write it R3 plus R2. You are doing operation on R3, so R3 will be written first. The rest of the rows will be written same as it is, like this. Now this operation on R3, you will get here 0, 0, 0 and 0. Now if you observe, you have 3 variables, K1, K2 and K3. But from here you got only 2 equations. The third equation is completely finished. So it means your one variable is free. And what does that mean that your one variable is free? It means you will let it equals to some variable. K3 is free. So this implies that let K3 equals to some variable t. Now from the second row, what equation you can get? 0K1 plus 16K2 plus 8K3 equals to 0. From R2, what you can write? 16K2 plus 8K3 equals to 0. So now it will be equals to 16K2 equal minus 8K3. You are basically separating the value for K2. So K2 will be equals to minus K3 over 2. And that is equals to, you know that what is K3? K3 is your T. Now from R3, what will be the equation? K1 plus 5K2 plus 3K3 is equals to 0. Now in place of K3, put the value of K3. In place of K2, put the value of K2. And get the value of K1. That will be equals to minus T over 2. Now what are your values? Your k1 is minus t over 2, k2 is t over 2, and k3 is t. All these are not equals to 0. It means you got a non-trivial solution. If all are 0, then this means you got trivial solution, but here you not got all 0. So it is a non-trivial solution. So due to the non-trivial solution, they are linearly dependent in R3.